Dear students, welcome to the second session of the DSP. In the last class, what you studied? In the last class, you studied about the DSP, introduction to DSP and basic elements of DSP, advantages and disadvantages of the DSP. In this class, you are going to study about the classification of signals. Continuous time and discrete time signals, analog and digital signal, deterministic and random signals, even and odd signals. So before going to study in detail the classification of the signals, first let us study what do you mean by the signal. Already you studied in the last class what is signal. Here also I am once again explaining you what is signal. A signal is a function of a set of independent variables with time perhaps the most prevalent single variable. Actually what happens, signal can be defined in many ways. One simple way of defining the signal is just it carries the information. For example, now whatever you are hearing my voice and all of you are seeing here, this is nothing but what the signal. Okay, but in the systematic manner, whenever you have to say means you have to say that a signal itself carries some kind of information available for observation. Correct? Another way is, in general, a signal is a function or a sequence of values that represents information. What do you mean by the signal? Overall, the signal is nothing but, I already told the example, whatever you are hearing my sound, that is nothing but what the signal. Signal is nothing but it carries the some kind of information that is available for the observation. Okay. These types of the signals are classified into 6 types. Okay, how many types of the signals are there? Totally 6 types of the signals are there. In that, first one is continuous and discrete time signal. Second one is analog and digital signals. Third one is deterministic and random signals. Fourth one is even and odd signals. Fifth one is periodic and non-periodic signals. Sixth one is energy and power signals. Okay, in this way what happens? There are the 6 types of the signals are there. In today's class we are going to complete this 4. Let us begin with the continuous time signal. Okay, continuous time and the discrete time signals. First, let us see what do you mean by the continuous time signal. Okay, we already told that the signal is nothing but it is a one representation. Okay, that means how you are declaring it is represented as x of t. That means it is a function of t. A signal x of t. So usually you think that x of t we represent as a signal. If x of t is a continuous time signal, here what happens? T should be continuous variable. If t is continuous variable, then the signal x of t is called a continuous time signal. Okay. So in another way also you can define as continuous time signal is nothing but the variable of time is constant. Okay. For example, so here you are getting the confusion. What do you mean by that continuous? What is the t should be a continuous variable? So here I am giving one example. Then it is very clear. A speech signal as a function of time is continuous time signal. Okay. So what is the example for the continuous time signal is nothing but what? That signal should be continuous with respect to time. Here I have shown the graphical representation. Time is moving from this end to this end. Okay, in the same way what happens, your voice is also, the signal is also moving. There is no break here. Simply, what is its name indicates? Continuous. Okay, so the continuous signal is there. When time is also moving, your your voice is also moving from this end to this end. That is nothing but what? The continuous time signal. Okay. So example is a speech signal as a function of time is a continuous time signal. Next, we use small t to denote the continuous variable for the continuous time signals. Okay, always you think that whenever we are saying that x of t is nothing but what? It is a continuous time signal. Okay, remember that x of t is nothing but continuous time signal. And another one thing is always we are using this t inside this parenthesis. We will enclose the independent variable in parenthesis. Okay, here t is an independent variable. Always we are using this for this representation. Only this is for our understanding purpose. Okay. Let us hope all of you understood what do you mean by continuous time signal. If the signal is represented as x of t, if t is a continuous variable, then x of t is called a continuous time signal. Okay, example is a speech signal is a example for the continuous time signal as a function of time is continuous time signal, and this is what your graphical representation of the continuous time signal. Now let us move to the discrete time signal. What do you mean by discrete time signal? It is also by seeing this word also you can imagine. Okay, that means the signal is not discrete. That is nothing but what? The discrete time signal. Here x of t, what happens if t is a discrete time signal, then the signal x of t is called discrete time signal. Discrete time signal is nothing but the variable of the time is discrete. For example, we can say that the weekly Dow Jones stock market index is an example of discrete time signal. That means they are telling the stock market is an example for the discrete time signal. Actually, this is the graphical representation. So, why they are telling like this means, so here in the graphical also you can see one x of n variable is there, but for the minus one, like it has this much of amplitude, or this the height of this is like this and like this. That means here the heights are decreasing or increasing, or it may come to the negative side also. That means they are not continuous. Important thing is they are not continuous. One example I want to tell you for this. Just you remember your academics. Let us say from 10th to 2nd PUC, BSc first year and BSc second year. Just you try to draw a one graph here. You take here 10th, 2nd PUC, first year BSc, second year BSc, and here you just write the percentages. How you will get? In the 10th you may get 80%. In the second PUC, once again 60%. In the first BSc it may be 90%, and in the second BSc it may be the 70%. That means this strength is not same. It is different. This is called a discrete. Understood? But when we are talking with respect to time, then it is called a discrete time signal. Okay? Let us hope all of you understood. Okay? If the signal x of t, when t is an, this is what your t. I will tell you once. Another one point is, always what happens, discrete signals are represented as n. Okay, and another one point, just you see, we are using this square bracket to represent this discrete time. Okay, don't confuse. Whenever we are using t, then it is nothing but a continuous time signal. But here when we are saying that when t is a discrete time signal, then we are telling that x of t is a discrete time signal. But to avoid this confusion, what happens? We usually use n for the discrete time signal, and in the square brackets we are taking the independent variables. Here you are seeing the same thing. Here in the continuous time signal we are taking the t, and here it is x of t, whereas in the discrete time signal this is n and this is x of n. Okay, if you are confusing with this statement, means you can delete this statement directly. You start this, then it is very easy to understand. Okay, let us revise once again. What is discrete time signals? Discrete time signal is nothing but the variable of time is discrete. Example is the stock market is an example for the discrete time signal. If you know or if you don't know, in the stock market what happens, every day there is changes. Okay, one day it is full high, one day low, medium, like that. So they have taken the one broad example for the discrete time signals. But you can compare this with your just now what I have explained about your results. And here the same thing I have given in the graphical representation. Okay, and another one point what you have to remember, we are using n to denote the discrete time, discrete time signal, and another one is we are using the square bracket to represent n. Okay, dear students, another one point just you remember, here just you change this n to denote the So another point is, a discrete time signal could be obtained from the continuous time signal by replacing t by n of t, where t is the reciprocal of the sampling rate or the time interval between the adjustment sample. This procedure is referred to as a sampling. Okay, another one point we have to remember, that if you replace this t in the continuous time signal by n of t, where t is what your reciprocal of the sampling rate or the time interval between the adjacent samples. This procedure is referred to as sampling. This in detail you are going to study in the coming slides. Okay. Next, let us move to the second one, that is analog and digital signals. All of you are aware with this analog and digital signals. Okay, what do you mean by analog signal? Analog signal means first it is a continuous time signal, that means x of t. It can take any value in continuous interval between A and B. First what happens, analog signal is the continuous signal if it takes the values in the interval between A and B, where A value is equal to minus infinity and B value is equal to plus infinity, then the continuous time signal x of t is called the analog signal. Okay. What is the analog signal? First, the analog signal should be continuous signal, and in that its value should be in the continuous interval, that too between minus infinity to plus infinity, then it is called analog signals. And next, what do you mean by digital signal? Digital signals is nothing but what? The discrete time signals. But it can take only a finite number of distinct values. Then we can call this as the digital signals. Okay. Digital signals are the discrete signals. Discrete signals, they can take only the finite number of distinct values. Okay. I can, if I want to just show the representation of analog signals, means you can take simply the sine wave as but it should start with minus sign, that is minus infinity to plus infinity. Simply I can say that the sine wave is an example for the analog signal. Digital is nothing but what? It is a discrete signal, and it can take the finite number of distinct values like this. Okay, like this. This is what your discrete signals. Here you are having some values as minus 1, minus 2, here it is plus quadrant, no, 1, 2, 3, and here it may be minus 1, minus 2. Okay, this is what is your discrete time signal means, x of n, only a finite numbers of distinct values, they are different. Let us move to the deterministic and the random signal. It is somewhat interesting, the definition. Let us see what is the definition of this deterministic signal first. Signals are termed as a deterministic if their behavior is known and can be represented. Okay. Signal is nothing but what? You can say that x of t is one signal if that signals are termed as that means if you want to say that the signal is deterministic, then what happens, that signal behavior should be known and can be represented by the formula. By using some formula, if you are able to represent that signal by some formula, then it is called a deterministic signal. For example, the deflection voltage of an oscilloscope is called the deterministic signal. Okay, so all of we are seeing the voltages in the oscilloscope, that is called the deterministic signal. Why we are going to call that as a deterministic means the behavior of that signal is known and it can be represented by the sawtooth wave. Okay, that is why that is called the deterministic signal. Okay, what is the definition of the deterministic signal means? A signal can be represented with a formula and we should know the behavior of that signal, then it is called a deterministic signal. Example is deflection voltage of an oscilloscope. Next, what do you mean by the random signal? It may be the opposite of deterministic signal. Okay. By contrast, we cannot define the amplitude values of the voice signals by means of formula or the graphical elements. Correct? In actually opposite of this is what? We cannot define the amplitude values of voice signals by means of formula or the graphical elements. In addition, their continued behavior is not known. Such a signals are termed as a random or stochastic. Understood? So I already told opposite of this deterministic. Actually, whenever if anybody is speaking means we can't measure the amplitude of that voltage. There is no formula for that one. That is why what happens, that type of the signals are called the random signals. Such signals are termed as a random signal. Since it is impossible to specify their behavior in terms of functions, such as signals are described by expected values such as mean, variance and many others. Then how we are going to describe that? It is not a function of time. Sorry, it is not a in behavior. We don't know the any terms of that functions. Then how you are going to describe that? Using the mean, variance and many other parameters, we are going to describe the random signals. Next is the even and odd signals. These even and odd signals are the same as even and odd functions what you studied in the mathematics. Just I will give you that. So we are having the mainly two types of the signals, that is x of t is nothing but what was continuous time signal. X of n is nothing but what? Deterministic signal. If I want to say that this is an even signal and this is an even signal, then what should be the condition? X of minus t should be equal to x of t is nothing but it is called a continuous even signal. If x of minus n is equal to x of n, then it is called a deterministic even signal. Okay, in the same way. So then what do you mean by odd signal? Odd signal is nothing but what? Once again, the same thing. A signal x of t or x of n is referred to as an odd signal if x of minus t is equal to minus x of t or x of minus n is equal to minus x of n. Okay, I think this is same as I think you studied in the mathematics, even and odd functions. Okay, x of minus t is equal to minus of xt, continuous even function, continuous odd function. X of minus n is equal to minus x of n. This is discrete odd signals. Okay, here I have to say signals, not the functions. Just I am comparing this with mathematics for better understanding. Okay, and in detail of this even and odd signals you are studying in the next class. Okay, and you can say that they are mutually exclusive. That is, if a signal qualifies to be an even signal, it cannot be odd and vice versa. Okay, so these are the some reference books I have used for this one. Okay, it is very important. Now stay home, stay safe, stay healthy. You are precious to your family. Okay, dear students, if you have any doubts, you can put the doubts in the Telegram group or in the comment box of this video.